Hi everyone, I am Shivom Karnad and I will be presenting my H AML IA1. So my topic is music style classification with CNN transformer hybrid model. So this is basically the introduction. So what happens in this approach is that we classify music styles using a hybrid model that combines CNNs, convolutional neural networks, and transformers. This work centers on transforming audio data into visual representations like spectrograms, allowing uh, allowing to achieve the strengths of to use the strengths of both CNNs as well as transformers for more accurate and efficient music style classification. So in this approach, basically, we use so in the traditional methods, basically what used to happen historically is that uh, we have heavily relied on time-based feature extracted audio. For example, RNNs, recurrent neural networks, or LSTMs, which is short-term, long-term memory networks, that have been widely used for analyzing audio sequences over time. These models focus on capturing the temporal dependencies of audio signals. So basically, while this time-based approach is has been effective, there is a new innovative method in which there's a fresh perspective, an image-based approach. So instead of focusing on temporal features, we convert the audio into images, specifically into spectrograms, and then these spectrograms are used to visualize the audio and capture the frequency content over time. This enables the use of CNNs, which excel at processing images, and transformers known for their ability to capture long-range dependencies. So why the shift to image-based classification? Now, there is a reason for this shift, and that reason is that the traditional methods, while they were successful, they often struggle to capture spatial patterns within the audio signals. And by transforming these audio into images, we can unlock the power of CNNs and transformers, which specialize in understanding spatial and contextual relationships. In the image-based approach, each spectrogram encodes rich spatial information about the audio signal. This allows the CNN to extract local features, while transformers help capture the global relationships across the entire audio sequence. Together, these two models provide a more comprehensive understanding of the music styles than either could achieve alone. Now, moving on to the actual implementation. So, the first step is of the audio transformation. The audio transformation, we start with the wave files, a lossless audio format that ensures there's high quality data for analysis. Then we generate spectrograms from these audio files. A spectrogram plots the frequency on the y-axis and time is on the x-axis, visually presenting the spectral content of audio over time. Essentially, it is a way to transform sound into forms that can be processed as an image. Once the spectrogram is created, it can then be passed into the CNN model, CNN transform hybrid model for classification. An example of a spectrogram or a more abstract example of a spectrogram is shown on the image in the right. Now, moving on to the actual backbone of the hybrid transformer model. The hybrid transformer model leverages again both CNN and transformers. CNNs are used to extract the local features from the spectrogram and identify particular patterns within the small segments of the audio. However, CNNs alone are not sufficient for capturing long-range dependencies. This is where transformers come into play, and they are designed to model global relationships, allowing us to understand the broader context of the entire audio sequence. By combining the local features, extraction capabilities of CNNs with the global context modeling of the transformers, we create a powerful hybrid model. Now, to further optimize the hybrid model, we use depth-wise separable convolutions or DS convolutions, which improve the efficiency by reducing the computational cost and the number of parameters without sacrificing the performance. Now, moving on to the experimentation and the experimentation setup basically consisted of using the GTZAN dataset. It is a well-known dataset for music style classification. It contains thousands of audio clips across 10 different music genres. And this was finally trained for 150 epochs in the research paper. And they used a learning rate of 0.001. to ensure a balance between the learning speed and accuracy. Um these results that later were generated were quite impressive because the hybrid model significantly outperformed the individual CNN or transformer models, achieving an accuracy of 84.5% on the GTZAN's dataset. This demonstrates the clear advantage of combining these two powerful architectures. Additionally, the introduction of depth-wise separable convolutions further enhanced the model's both efficiency and accuracy. Now, coming on to the ablation studies, uh, the ablation study and the insights. The ablation study was to evaluate the contribution of each component of the model. It became evident that the combination of the CNN and transformer achieved the highest accuracy, as mentioned before, proving that the strengths are complementary. Moreover, the use of DS convolutional layers provided notable gains in efficiency, making the model more scalable and suitable for larger data sets in the future. Now, coming to the final conclusion of this entire research paper, the conclusion this work presents a cutting-edge solution for music style classification by transforming audio data into images and utilizing a CNN transformer hybrid model. By capturing both local and global patterns, the approach provides a more nuanced understanding of the music styles than traditional time-based methods. The audio to image transformation enables the model to exploit spatial features within an audio, and the CNN transformer hybrid architecture effectively harnesses both the local and the global information. Ultimately, the model achieved state-of-art results on the GDZAN's dataset, setting a new benchmark for music style classification. Thank you for listening, and I think that's all from my side. Thank you.